Gentlemen, welcome to the Victoria Memorial Hall on an occasion where we shall have the opportunity to discover the beauty and aesthetics in science, an illustrated lecture to be delivered by Professor Bikash Sinha. I would like to first request Dr. Jayanto Sengupta, Secretary and Curator of Victoria Memorial Hall, to welcome the audience and also to introduce Professor Bikash Sinha.
Good afternoon, everybody, and a very warm welcome to this afternoon's talk by one of the leading luminaries of Indian science, Professor Bikash Sinha. As you know, we have been trying to reinvent the Victoria Memorial Hall as a place, as an open-ended space for conversations about many things, not only about art and culture, but about many things. And in keeping with that objective, we have of late, in the past couple of years, hosted some lectures on popular science. So we have had lectures given on popular science by Professor Shobhasachী Bhattacharya, the physicist, and then again Professor Palash Boron Pal a few months ago, Professor Shomak Rai Chaudhuri on astronomy, and then today it's our absolute privilege and honor to have Professor Bikash Sinha to talk about beauty and aesthetics in science. So although we are having a talk on science, we will have a talk which will dwell very broadly. This is such a wide-ranging and all-encompassing topic. So I suppose that we will not be very far away from art, literature, culture, and heritage. Now, it's I don't have the temerity to introduce Professor Bikash Sinha here. He doesn't need an introduction. Everybody knows him. He's a star. He's a heavenly body in his own right. So I will not try to do that, but I will, in keeping with tradition, I will just mention a few of his many accomplishments. It's not possible to give a full account of them because it will take a long time. But just a sort of brief bio and some of the major awards that he has won. Professor Bikash Sinha was born in 1945 and he graduated in science with a first class from the University of Calcutta. He obtained his tripos in natural science from the University of Cambridge in 1967 and obtained his PhD from the University of London in 1970, following it up with a doctorate of science in 1981. He lived in England for more than a decade, teaching and researching in the Rutherford High Energy Physics Laboratory and then King's College London. King's College London. So in 1976, after coming back from England, Dr. Sinha joined the Bhabha Atomic Research Center and in 1987 was appointed the director of the Variable Energy Cyclotron Center, of which the Radiation Medicine Center in Kolkata is a part. He also became a fellow of the Indian National Science Academy as recognition of his outstanding research in physics, and this was in 1989. He is also a fellow of the National Academy of Sciences, Allahabad. Dr. Sinha held the concurrent charge as director, Saha Institute of Nuclear Physics, Kolkata, from November 1992 to June 2009. He has been the holder of the distinguished Homi Bhabha Chair of the Department of Atomic Energy, Government of India, from 2009 to 2014. Professor Bikash Sinha has been conferred the Padma Shri Award by the Government of India in 2001 and then the Padma Bhushan Award by the Government of India in 2010 for his significant contribution in science and technology. In addition, he has been awarded numerous other prestigious awards, honors, and prizes, including the Satyendranath Bose Birth Centenary Award of the Indian Science Congress Association in 1994, the Dr. Raja Ramanna Prize in 2001, the R.D. Birla Memorial Award of the Indian Physics Association, of which the other recipients include Professor Abdus Salam and Professor Subramaniam Chandrasekhar. The Rais Ahmed Memorial Lecture Award, Aligarh in 2001, the Humboldt Research Award by the Alexander von Humboldt Foundation, Germany in November 2005. Recently, he was awarded Professor Meghnad Saha Memorial Lecture Award in 2007 from the National Academy of Sciences, India in 2007, and has been elected as president of the Indian Physics Association from 2007 to 2010. He was awarded the Meghnad Saha Medal of the Indian National Science Academy, INSA, in 2015. Recently, Professor Sinha was appointed as Distinguished Visiting Scholar to Christ's College, Cambridge in 2009. He was also elected to the Fellowship of the Third World Academy of Sciences in Italy in 2002, the Indian Academy of Sciences, Bangalore in 2004, and of the Institute of Physics in London in 2009. The Honorable Prime Minister of India has nominated Professor Sinha as a member of the Scientific Advisory Council to the Prime Minister from January 2005 onwards. The Ministry of Human Resource Development has also recently appointed Professor Sinha as the chairman of the Governing Council of the National Institute of Technology, NIT, in Durgapur from June 2005 to December 2014. Professor Sinha has been conferred the Doctor of Science honoris causa by the National Academy of Sciences of Ukraine in 2005, the National Institute of Technology, Silchar in 2010, Bardwan University in 2012, the Central University of Koraput in Orissa in 2012, the National Institute of Technology, Agartala in 2013, the Netaji Subhash Open University in 2013, and by the University of Calcutta, his alma mater, in 2014. I wonder why that was the last of all. Professor Sinha became a member of the Presidency University Council in 2010. Professor Sinha has become a member of the State Planning Board of the Government of West Bengal since September 2011. He has been the chairman of the Council of the Bosch Institute since September 2013 and is still holding that position. Currently, Professor Sinha is the emeritus scientist of the Indian National Science Academy. He has published more than 250 papers. The pioneering work on quark-gluon plasma is already well recognized internationally. He led the team from India to participate in the experiments at CERN in Geneva. He, along with his other colleagues, established the thermometric signals of the quark-gluon plasma as a definitive signal, and this has been confirmed by experiments. Among his many, many published works, there are books in Bengali. He has recently authored a book in Bengali titled Srishti O Krishti, which has made a huge impact on many readers. And the latest book in Bengali, authored by Professor Sinha, is titled Sthan, Kal O Bisholo, which has also been received with much appreciation, and I suppose some of the areas covered in these books will come up for discussion in today's lecture. So that's all I have to say for now. It's an absolute honor and privilege to have Professor Bikash Sinha to speak on beauty and aesthetics in science. And before I invite Professor Sinha, I would request you to please take a moment to put your mobile phones on silent mode or switch them off because we do not want the lecturer to be interrupted by those very alien sounding sounds from your mobile phone. So please take this moment. Yes, I guess. But that's the kind of beauty that we could do without this afternoon. So, ladies and gentlemen, please join me in welcoming Professor Bikash Sinha to talk about beauty and aesthetics in science. Professor Sinha.
Professor Jayantu Sengupta, my dear friend Krishnan Srinivasan, other friends, ladies and gentlemen. In my life, of course, by now one has given many lectures, which is not surprising, but it's never quite the same pleasure as giving it in Victoria Memorial. And because of the structure of this hall, one can feel the ambience inside, as a matter of fact. And Lord Curzon, the creator of Victoria Memorial, although not a very pleasant man, rather pompous and arrogant, but I believe he had a sense of aesthetics in architecture. And he is one person who actually managed to go to all places, Vrindavan, to see the temples. There is some historical anecdote on that. So it's a very beautiful place. I'm very grateful to Johnson for inviting me to give a talk on beauty and aesthetics in science. Now, one doesn't associate science with beauty or aesthetics. One generally associates science with very loud sound of mathematics and very dry. It's not. What I want to demonstrate in the next 45 minutes or whatever is to show you that underneath the science there is this beauty which dominates quite often the driving force of creativity. So science is not just a rational pursuit of reality and in the process unraveling the mystery of nature around us, but at the core of it lies great beauty and aesthetics. This point would come back again and again as we go along in the talk, in the first part of my talk. And I watch your eyes very carefully. Once I see you begin to lose interest, I'll just stop, okay? Albert Einstein said a long time ago, one of the strongest motives leading to arts and science is a flight from everyday life, which is painful coarseness and bleak tediousness from the chains of the ever-changing personal wish. I must say, so many thoughts have gone in that small paragraph. It's mind-boggling, but it's absolutely right. I start off with the famous conversation between Tagore and Einstein way back in the last century. And when Einstein meets Tagore, and they met several times in both Europe and America, the Western concept of plurality, and I'll try to explain that, always clashed with the Eastern concept of singularity. This singularity has nothing to do with Big Bang singularity, which I'll come to. It's a singularity, which is philosophic singularity. This is July 14, 1930. AE means Albert Einstein, RNT means Rabindranath Tagore. Truth then, or beauty, is not independent of man? No. If there be no human beings anymore, the Apollo of Belvedere will no longer be beautiful? No. I agree with regard to this conception of beauty, but not with regard to truth, Tagore. Why not? Truth is realized through man. I cannot prove that my conception is right, but that is my religion. He invokes religion very early in the dialogue. Beauty is the ideal of perfect harmony, which is in the universal being. Truth, the perfect comprehension of the universal mind. You see, the bend of words of Rabindranath Tagore is not particularly matching with the bend of words of a theoretical physicist brought up in the German tradition. Through our accumulated experience, through our illuminated consciousness, how otherwise can we know truth? I cannot prove scientifically that truth must be conceived as a truth that is valid, independent of humanity, and so on and so forth. The conversation goes forward and backwards. But such a truth cannot belong to science. The nature of truth which you are discussing is only an appearance. That is to say, what appears to be true to the human mind and therefore is human may be called Maya or illusion. Einstein and Rabindranath got entangled with the eternal conflict of the plurality of the West versus singularity of the East. Schrödinger, great physicist who discovered wave mechanics later on, came into the picture with a book called What is Life? And there he talks about consciousness, spirituality, and all that sort of stuff, which is written there, and equating Brahma of the Vedic school to Atma. So Tagore again goes on saying that in a later part of his life, Religion of Man, there are thinkers who advocate the doctrine of the plurality of the worlds, which can only mean that there are worlds that are absolutely unrelated to each other. Even if this were true, it could never be proved, for our universe is a sum total of what man feels, knows, imagines, reasons to be, and of whatever is knowable to him now or in another time. In fact, the poet wrote Shamoli. The title of the poem is I. This is clearly singular I, not plural I. You know all of it, most of you know about it. The color I have translated that, do forgive me. The color of my consciousness turned emerald to green. Ruby turned crimson. I looked upon the sky, the light was lit. I looked at the roses, said beautiful, they became beautiful. I look at it, therefore they became beautiful. This is the point to note. Now I turn briefly to the concept of space and time, which are probably most common to think of. This is space, and every time I speak, another moment passes, that's time. This is the usual idea. But believe me, ladies and gentlemen, my friends, we do not know what space is or time is. Singularity of space-time was the point of creation of the universe, the Big Bang. Do we measure time from that point in time? Big Bang singularity, when the universe was created? How is space created? At that time there was no space. Not entirely known. There are emergent problems. So there again, invoking Rabindranath, I had difficulty in translating the word Shesher Kobita. Shesher Kobita means Kobita of the Shesh, right? End. So eventually came poem of the end. Maybe you don't agree with that, but that we can discuss without much meaning to discuss really. Have you heard? Have you heard? The whisper of the eternal journey of time, starting the beat of life, heartbreaking cry of the stars, crushed in the darkness by the wheel of time. How is space created? We don't know. It's emergent. How is time created? We don't know. But crushed in the darkness by the wheel of time as a poetic concept, if that is not beautiful and aesthetically supreme, what else can it be? And incidentally, in terms of science, space and time are inclusive coordinates of all science. From Newtonian gravitation to Einsteinian general theory of relativity or gravitation, from millions of neurons in our brain to billions of stars in the cosmos, from the microcosmos to macrocosmos, from the quarks inside the protons to the molecules of the DNA, from the electromagnetic waves to gravitational waves, from plurality to singularity, from life until death, in fact from the very beginning to the end. But all this manifestation of space and time, there is that altogether tranquil and all-pervading beauty. Please don't worry about that equation. People still trying to find out the meaning of that equation, which Einstein wrote down in 1916 while discovering the general theory of relativity of gravitation. And I have written down for your reference what these numbers mean, but don't worry about it. It's too complicated. Man has suffered because of that one equation. Try to find out the riddle of that equation. What is interesting is the point lambda. You can see the lambda just before it becomes the equal sign. That's called the cosmological constant. And Einstein apparently said the cosmological constant, being non-zero, is the biggest blunder in his life. Although I must confess to you, I never found out the source of the statement. Probably some people who thought he said. A lot of people think somebody has said something. Rabindranath said something, but he didn't actually. Or Einstein said something which he never did. Rather, the man who is saying that, he thought he would probably like to say that. So lambda, cosmological constant, it has been discovered recently by observation that it makes our universe accelerate faster than we knew before. Just imagine, you're sitting in a universe, a very small part of it called the Earth, and there it is expanding because of the cosmological constant. So let me explain to you. It's a repulsive gravitational field. Gravity attracts, a cosmological constant repels. And because it repels, the universe goes on accelerating. Universe will continue forever in the same way, expanding universe, accelerating universe. And that led to a discovery very recently, last 10 years or so, existence of dark energy. Dark because we don't know what it's all about. And of course, the existence of dark matter. And you will see a little later that most of the universe consists of dark matter and dark energy. And the visible ones, like us, is a very, very tiny fraction of that.